Okay. Yep. Oh, good, everyone. Just want to check if everyone can hear me crystal clear. I will. Yep. Okay. Oh, good. Okay. Good morning, everyone. I just want to welcome everyone to Fit 5136 Software Engineering Unit again. This is week 6 already. Today, we're going to cover the topic around the introduction to software quality assurance and software testing. I hope everyone had a good Easter break. Yeah, is that right? Yeah. Okay, so let's see what are we going to talk about it today. This is just a reminder, we have learned the high level of the software engineering process. We talk about the Agile Scrum project management in the past few weeks. We elicit the requirement already. We manage the project. We know how to manage the project. And right now, for the assessment 3 and the assessment 4, we will talk about the software development part, the project management part, and the software testing. How can we deliver the software without testing them, right? Because the quality is the utmost important topic here. We cannot deliver the software or products that are full of bugs, is not usable at all, So, but that's why we need to learn about what is the software quality and how can we test them, right? And what are the quality attribute? What do we mean by the software quality? What is that definition? So we're going to talk about that today. Okay, so today we will talk about why the software quality is so important. There are so many different quality attributes as well. We will talk about the high-level concepts of the software quality assurance. There are different aspects of the software quality assurance SQA, and how can we test them? There are different SQA and the software testing approaches as well. So we'll talk about that. All right. Yeah, so basically, I will start with this one, right? What exactly is the software quality and testing? So I would say that when we talk about software quality, it is something that cannot be compromised at all. When we develop the software products, we want to ensure that uh, it is highly reliable, it is no bugs, it is functionally correct, it is highly usable, with the user friendly, that kind of thing. There are so many quality attributes. So when we talk about the software quality, by the definition, it means that it is the degree to which a product or a process meets the requirement. All right. So when we start the software development projects, we need to write the requirement specification, as you remember, software requirement SRS, software requirement specification. We need to write what is the functionality of the software system. Is there any technical requirement or not? And then whenever we meet that kind of requirement, we refer that it is of high quality. Okay. So to ensure that it is of high quality, there are different software testing techniques to detect or to test the software, whether the software meets the requirement or not, right? And we can use it to find bugs, or the faults as well, Yeah. So this is what we are going to talk about it today. Okay. Why do we need to care about the software bugs or the software quality or software testing, right? There are so many like a headline news, that shows that software bugs actually cost like several $trillion globally. Okay, as based on the report here, the URL from the Microsoft, it shows that it has a direct cost to the US annually, like $59.5 billion every year, and it costs $29 billion every year to Australia as well, right? And there are lots of headline news about the software bugs, and they are really annoyed. For example, let's say if you go to the Woolworth, you want to check out the products, right? You want to purchase something, but the self checkout system is actually failed, right? And then how can you actually buy something from the Woolworth, right? And then that's why it shows in the headline news that when the Woolworth delivery system outage, right? So it leaves a customer hungry at home, that kind of thing. in the hospital domain, right? They use lots of software as well to for the medical prescription, that kind of thing. And then, what do you think if that kind of software overestimate the dosage or underestimate the dosage? It provide inaccurate prescription to the patient, that kind of thing. So it actually can kill the patients within a month as well, as you can see in the news here, right? Same to the banking domain, right now everything is digital. You use a credit card, you use the PayWave to tap or to buy something, right? Or to you have a mortgage or that kind of thing. What if this kind of account disappear from the online banking system? So the customer cannot access the bank, they cannot access the money, that kind of thing. Okay, so this is just an example how the failure in the software system actually impact our life a lot, right? And when because the software has been used in different sectors and different domains, like not just only the online shopping system, but also in hospital area, digital health area, in the space, in the rocket system, so a failure to eliminate the defects in safety critical system could result in serious injury to people, threats to life, death, or the disaster as well, Okay. And nowadays, right, everyone use Facebook application, Twitter, X, or TikTok, or whatsoever. The software, it actually evolves extremely fast. And right now, it is really complex, right? Because they are written in multiple languages by thousands of the developers over a long period of time, like 10 years, So during this like a 10-year period, they need to fix the bugs, add the new features, improve the code quality, that kind of thing, okay? That's a report from the Google. They shows that 50% of the Google code base, okay, think about the GitHub repository. 50% of the GitHub code base actually change every month. How fast the software is evolved over time, right? And think about the Microsoft Windows as well. Right now, it has like over 100,000 code changes, right? So, and the software is released faster at a massive scale as well. Think about the OpenStack, which is like an open source cloud computing system, right? They release every 6 months. Ubuntu, a kind of like operating Linux operating system, they release every 6 months as well. April and October. Mozilla Firefox, the web browser, okay, they release every 6 weeks. Facebook, Netflix, Twitter, they release every day. Everything like they just want to release the new feature every day, fix the bugs, everything is continuously delivered to the end users, right? So the key question as a software engineers or project managers, right? How can we effectively and efficiently assure the quality of the software system at the lowest operational cost? What we mean is that we can fix the bugs like for 10 years, by just one bug, but is that really cost effective, right? So it's not. That's why we need to engineer the software system, engineer the quality products to make sure that they are at the top quality. There's no bug at all. But how can we do that effectively at the lowest cost, right? That's why we need to understand the principles of the software quality assurance and the modern software testing technique, okay? By the definition, software quality assurance is a set of activities or the processes. They aim to ensure that the software products meet the quality standard. At the moment, there are different quality standards that have been used in the software organization, like ISO 25010, SPICE, or the CMMI, the maturity model, that kind of thing. So there are different standards that have been used nowadays, right? But in the general principles, they really focus on the three things, okay? The three goals here of the SQA. They want to ensure that the product, okay, has the design quality properties. And the process by which product was built is also sufficient quality as well. And that means that's why when we talk about the software quality assurance, we focus on the product and the process. The product must be the best and the process must be efficient as well, okay? We cannot just like fix the bug with the like poor process, poor QA process. Everything is so manual. We run the test case one by one. It would take like a year to finish it. Right now, everyone just use test automation already, right? So that's why the product must be the best. the process must be the best as well. Okay, and in real world software organization, who cares about the software quality? So based on this white paper here, right, there are actually three stakeholders who care the most, right? First, definitely the end user. Whoever use the software system should care the most, right? They want to use the high quality application whatsoever, right? The development team, the people who develop the software, they should care about the software quality. And the sponsors of the project could be the company, you know, whoever paying for the software creation, that kind of thing. Look at the figure here, right? Normally, the goal of the software company, okay, they want to turn the idea into the real world software products here. So there must be a development process along the way, right? So the process must be quality, must be the best. The software must be the best as well. And there are the three stakeholders here that are involved as part of the software quality assurance. Okay, the sponsor, the users, and the development team. When we talk about the software quality, that we can look at different aspects of the software quality. Okay, um, and here we, as I mentioned before, when we talk about the software quality, it's about the degree of conformance to the explicit or implicit requirement and the expectation. So that means, I mean, in short, right? Software quality, it means that how well the user satisfy the products, that kind of thing. Okay, that's a user satisfaction. We didn't develop the software for ourselves, but we developed the software for the end users, right? Who care the most, you know? So when we talk about the software quality, we often, this is the quality pyramid, okay? We look at the three aspects here: the functional quality, the structural quality, and the process quality. As I mentioned before, functional quality, we talk about whether the functionality of the software product is correct or not, right? A plus A, we talk about the addition function in the calculator, you know, 1 plus 1 should be equal to, you know, that's the functional correctness, okay? But we also, it's not just only the functional correctness, but we should look at the structural quality as well. How well do we decide the quality of the, how well do we design the architecture of the software system, right? We talk about the non-functional requirement, usability, maintainability, understandability, whether the code is understandable or not. We look at the efficiency of the software system of the code. We look at the security aspects of the code as well. What about ethics of the functionality of the software system, that kind of thing. Okay, so I mean, in short, right? When we talk about the quality, we look at the functional quality, non-functional quality, okay, and the process quality. Whether the development process is actually like efficient, it is of high quality, it is at the lowest operational cost or not. Okay, we cannot look at the quality for 10 years. Okay, we need to make sure that everything is efficient and effective. Yeah. Okay, when we talk about the quality assurance or the quality management, you know, there are the four components here. We talk about quality planning, quality assurance, control, and the improvement, right? This is like a general process. At the beginning of the software products, we need to make a plan, you know, we need to make a plan. We need to develop the quality planning. What do we mean is that, let me think about back to the requirement requirement engineering lecture. We talk about the definitions of done. As you remember, right, we define the quality of the what is the done, definitions of done, when the user story is met, that kind of thing. The code coverage must be achieved like over 80%. The code must be reviewed by X numbers of the reviewers. It must be well tested. It should be run against the static analysis tools or whatsoever, right? That's the quality planning. We make a plan. We develop the standard of the whole project. Okay, this is for the whole project. We need to set up the plan, the standard first. Okay, and then that's why as part of the planning, quality planning, we need to develop the process. First, let's say if you use the GitLab, right? GitLab, you can set the process where okay, any new code contribution or the pull request should not be integrated into the main branch, but it should be like a new branch first. It must be reviewed by the other two reviewers. It should be well tested, achieve like X% of the code coverage, that kind of thing. That's the standard that you set it up and as part of the QA process as well. Okay, makes sense? When we talk about the quality control, it means that how do we measure the quality? Okay, for example, the control measurement, okay, measurement could be let's say for the whole project, the code coverage must be over 80%. That's how you control the quality. Okay, the bugs must be less than X%. You know, the bug report should not be open more than X numbers, that kind of thing. Everything must be quantifiable, everything must be measurable. That's the quality control. Okay, and over time you have the quality planning, you have the QA process, you have the quality control. Over time you learn from the mistake, and then you can develop the quality improvement plan as well. In the past, we found that code that is quite large, you know, large file size tend to have the higher numbers of bugs, that kind of thing. And that's why in the future, you can develop the quality improvement plan as well, that, hey, look, the next file size, in the next iteration or the next revision, the file size should not be larger than 500 lines of code, that kind of thing, you know. This is a kind of like a quality improvement plan. So these are the 4 components of the product quality management that you need to consider. All right. Okay. As part of the SQA planning, right? What exactly it is? Okay, it is like a systematic approach to identify what is the quality requirement, what are the activities, processes, or the standard that will be employed in the project. And what we mean is that we just need to justify the sufficiencies of the measures to provide the desired level of quality. It doesn't need to be like extremely detailed, but just enough, okay, quality measures, requirement, that kind of thing to maintain, okay, to control the project, okay, to control the quality of the software products. Does it make sense, everyone? Yeah. So that's the part of the planning, okay? And in the past, let's think about the waterfall, right? They need to develop like a SQA planning document, okay? Let's look at the, on the left side, okay? These are the key questions that we need to include it in the SQA planning document, okay? For example, who is responsible for the SQA activities in the past? There will be like a QA department, software testing team, that kind of thing. What are the SQA activities that need to be performed? Should we also look at the code only or the non-code artifacts as well? Okay, so quality is not just only the code, but we should also look at the quality of the design as well, design quality, whether the class is like a really complex or not, high coupling, low coupling, that kind of thing. Okay, we will talk about that in the workshop today as well. Okay, and what are the processes that need to be performed, right? Who needs to be involved in the SQA activities? How many testers that need to be done? We work on this project. How extensive should SQA activities be? You know, what and how will software quality be measured? How can we measure the software quality? By the numbers of bugs, by the code coverage, or by the numbers of the reviewers who review the code, that kind of thing, you know, code complexity. There are so many software measures here. How will the results of the SQA be made available to the relevant stakeholder? How do we report it? Okay. Look at the table of content here, you know, in general, what is the purpose of the SQA? What is the scope? How do we manage the quality products? What are the tasks that need to be done? What are the roles and the responsibility for each of the person in the team, you know? What is the minimum documentation requirement? What is the standard that we are going to use? Is that the ISO standard or the CMMI standard? You know, what is the standard matrix here? How do we measure? How do we conduct the code review? That kind of thing. This is like a planning. But what I mean is that the planning here or the quality standard, in the past, it is heavily used in the waterfall, right? But nowadays, I would say that we don't have like a specific planning for each of the project, but the organization has the quality standard as a whole. The Microsoft companies, Google, okay, they also have their own quality standard as well. They already define what it should be. Okay, you can just Google SQA standard in Google, that kind of thing. Okay, and this is an example of the quality attribute. Okay, based on the ISO 25010. Okay, quality attribute based on this standard. Okay, ISO standard. What are the quality attributes that we actually consider? First, we should look at the functional suitability. Okay, functional suitability, what does it mean here, right? Functional completeness. When we develop a calculator application, okay, what is the basic functional completeness? Okay, addition, subtraction, multiplication, division, that kind of thing, right? If we develop only addition, is that complete? No, probably no. What about the other three functions, that kind of thing, right? So it's not of high quality. Functional correctness, whether the addition, each of the function here in the calculator class is functionally correct or not, right? And whether the function that we develop is appropriate or not as well, okay? But it's not just only the functional suitability. We should also look at the performance efficiency as well. What if a calculator app do the 1+1 operation, but it takes like 10 minutes, to get the response, to get the answer. So the time behavior is actually one of the key factor as well, right? The responsiveness of the application, right? So this is something that we need to consider. What if we have what is that? The calculator, but actually utilize like high it requires like high performance CPU. Do we really need that, right? So it's not like too expensive, right? So it's not that really efficient for that kind of application, So in general, okay, in summary, we should look at the functional suitability, performance efficiency, whether the software product is efficient or not, whether it is compatible or not, right? When we develop an application for iPhone application, would it compatible with the Android mobile devices or not? Whether the UI of the mobile app is usable or not, right? There must be like the right format for the numbers, for the positions of the mathematics operation, that kind of thing, plus minus, addition, multiplication. So it should be usable. You can think about the design principles that we have taught in the past as well. Okay. Whether the software is reliable or not, this is another one factor that we need to consider. Security. Think about your what is that, the online shopping, Monash merchant. How do you keep the username and the password? Is there any encryption someone can hack or not? You need to make sure that your application is actually secure. And what about the maintainability issues? Okay, whether the software is highly modular or not, is that like a too tangible or not? Is it highly reusable or not? So there are so many aspects that you need to think about it as well. Portability as well, okay? So in short, these are the, what is that? How many quality attributes? 8, right? Okay, these are the 8 quality attributes under the ISO standard, okay? This is a very classic standard that everyone understands, okay? Yep. And what else? I would say that, okay, so for this framework, one thing that I'm missing, I forget to tell you, is that when you look at the, maybe I should have draw here. So for this framework, we actually look at both functional and the non-functional, okay? So here, only this one is the functional quality, okay? But the rest here is the non-functional. There are so many non-functional requirements, non-functional quality. We look at the efficiency, compatibility, usability, reliability, security, maintainability, and the portability. All right. But when we look at the functional correctness, functional quality, we have to make sure that the software is functionally complete, functionally correct, and it is appropriate as well. All right. Any questions so far? Okay, next, what is that? Oh, basically, I just define what are they, okay? I will just skip. I don't need to talk about that. We talk about the software quality as well. No, sorry, we already talk about the software quality. What it is, there are different quality attributes. But the key question is that how can we test them? Okay, this is the six high level, six general software quality assurance or the software testing approaches. Okay, we the basic one. Okay, so it's called software validation and the verification. The next step is the waterfall style SQA. What does it mean? We'll talk about that. Why do we need the shift-left testing? Why do we need to shift? I will talk about that as well. What is the test-driven development, agile testing, and the DevOps testing? Okay. All right. Let's take a break. Okay, for 10 seconds. Let me have a sip of water. Okay, verification and the validation. I'm pretty sure that most of the students is aware of this one before, or some people call the V model. All right. What is the verification and the validation? Okay, so let's start with the first one. Verification. We often talk about, are we building the product right? Okay, are we building the product right? But for the validation, we ask the other question, are we building the right product? It is different. Okay, yeah. So when we talk about the verification, we actually we want to ensure that the software or we want to ensure that the software meet the requirement. Okay, but when we do the validation, we want to check whether the software meets the client need or not. Okay, so what does it mean here, right? Let me see. So if you look at the V model, the figure on the right hand side, this is the V software, the V model software process. Okay, we often start from the requirement. We do the high level design. You do the class diagram, sequence diagram, that kind of thing. You do the detail design. You do the detailed class diagram, and then you start the coding. And then we will talk about the unit testing, integration testing, system testing, and the user acceptance testing. User acceptance testing, if you remember, when you create the user story, you need to create the acceptance testing. Do you remember? How do you actually test that user story? Okay, it's not okay, yeah. And if you look at the legend here, the light gray is the validation, the dark gray is the verification, right? What does it mean? When we talk about the verification, are we building the product, right? So it means that, let's say the calculator app, are we building the addition correct or not, right? 1 + 1 = 2. That's why when you do the coding, you need to write the unit test to make sure that 1 + 1 is actually equal to 2 + 2 is actually equal 4, that kind of thing. So when we do the verification, we often do as part of the unit testing, integration testing, and the system testing. But when the software, the function is verified, everything is correct, but we need to validate with the end user as well. So that is part of the acceptance testing. Okay, here, right? So we want to validate with the end user whether the calculator is actually correct or not, right? Think about this is the calculator application. You have the display, you have the button whatsoever. But if the button is not in the right order, probably the software, the calculator app here is correctly verified, but it's not. It is invalidate. It's not accept at the user level. Okay, so it doesn't pass the acceptance testing. Yeah, is that clear, everyone? Yeah. That's the difference between verification and the validation. Verification, we look at whether the software is correct or not, right? Are you building the product right? Validation, are you building the right product? Okay. Are we building the right product? Yeah. Okay. Next, that's the first, the basic one, V model. And then the next step is the waterfall style SQA. when we talk about the software, when we talk about the waterfall software development process, right? We start from the analysis requirements, and we get the requirement, we analyze the requirement, we develop the requirement specification, break it down, make it concrete. We design the software based on that requirement specification. We start the implementation, and the testing and the integration is the whole phase of the SQA. Okay, no, SQA only focus on the testing and the integration phase here. Okay, so after you implement everything, the funny thing is that you just start, analyze the requirement, develop the test plan, develop the test case, set up the environment, execute the test case, and finish the test cycle. You know, what happened is that the key limitation here is that it is quite too late, right? It's really nearly at the end of the process. So it's not efficient and effective at all. There are a few limitations here, okay? First, it is quite siloed with the poor communication and the collaboration, right? Not at the beginning, the requirement engineers start working with the software engineers, but they don't talk with the QA department, quality engineer, or the software tester at all. How can we ensure that such kind of the requirement is testable, and how can we test that kind of requirement as well? What if the requirement change? Tester is not aware of that as well. Tester, they don't understand the business domain, because they start at very late of the software projects, right? And they don't understand the requirement. Testing is at the end. Tester don't involve early as well, and only tester take the responsibility. What about the requirement? What if the requirement is unclear at the beginning? How can we actually test it, right? So that's why right now we have the we tend to use the agile, we tend to use the cross-functional team. You know, everyone should start from the beginning at the early phase of the software development project. Okay, and what happened with the waterfall is that, right, the majorities of the defects are introduced early, but they are detected later. Okay, so if you look at this figure, right, majorities of the bugs are introduced during the requirement and the analysis design. When the requirements are not clear, they are not captured, they are not elicited well, there's a box in the requirement already. We need a calculator. But what are the functionalities of the calculator app, right? If they are not well elicited, if they are not well defined, how can the software engineer and the software tester can actually test them and develop them? It's impossible. That's why later on, most of the bugs, they are detected during the acceptance testing. This is the requirement, we develop it, but are we building the product, right? We don't know until we test with the end users, right? So the bugs are detected too late, and it is very costly to fix the bugs at the end of the software development projects, right? So that's why we ask the question, how can we shift the QA process to the early phase of the software development? That's why we have the shift left testing, the concept here. Okay, the goal of the shift left testing is to find bugs as early as possible at the early phase of the software development. Okay, by doing this, developers can fix the bugs, okay, before they can cause major problems. And by finding bugs early on, companies can avoid the costly process of the fixing these bugs after they have been deployed. All right, let's take a look. What does it mean? Okay, in the past, you know, when we do the testing, right, when we test at the end, that's like a shift, right? Okay, we test at the end, but right now we want to shift to the left. So test at the early phase of the software development. Okay, what do we mean? So when we start the software development projects, we should bring the tester or the QA department on board as well. And what do we need to test is, first, we need to test the requirement. When we have the new requirement, we need to think about whether that user story, that feature is testable or not, right? We need to test the new code. When we develop the new code contribution, we need to test it. We need to test every build as well. We talk about the continuous integration, continuous deployment, okay? Testing every deployment, CI/CD, and testing on production as well, okay? no, sorry, testing on production is something that we need to avoid. That's what I mean. I'm so sorry. That's the chip, right? Okay, we should avoid testing on production. Okay, and if you look at this figure, all right, so when we attention to the quality, right, if you look at the traditional approach, okay, we focus on the testing at the end of the project, right, during the deploy and the release. Oh, we're gonna release a new feature, we don't have time, let's test on production. So release the app, let the end users find the bug, submit the report to us, we're gonna fix them. But you're gonna end up with the bad reviews in the app store, that kind of thing, you know. Oh, the bugs are no, sorry, the apps are full of bugs, you know, so crash, it is so buggy, that kind of thing. And that's why it is really costly when you get the bad reviews in the app store. Let's say this is a context of the mobile application, right? You cannot fix them unless you deploy a new application, you know. When you deploy the name Facebook app, is the Facebook forever, okay? You cannot even change the name, okay? So that's why it is really costly to fix everything, not just only the software, but also the company reputation as well, the development team, everything. That's why we want to shift the testing process to the early phase of the software development, okay? That's a chiplet concept here. Test from the planning and the design. Start testing early during the development and the build process, but let's test during the test here. So test here should be the acceptance testing already, or the test every build, every the deployment, that kind of thing. Okay, makes sense, everyone. That's a chiplet testing. DevOps testing, what does it mean here, right? So when we do the chiplet testing, it's not continuous, okay? As I mentioned before, nowadays software is released continuously, okay? We deploy the new feature continuously. We don't need to, how can I say, we let the computer, okay, execute the test automatically. Everything is automated. So we don't need to have the human involved now, okay? So that's why we use the DevOps testing, okay? Nowadays we use the DevOps testing, because when we let's think about the mobile application again, okay? Or mobile application. Think about the Facebook app, okay? Facebook app, you see the app on the mobile phone, but it has to connect to the API server, to the third-party system, that kind of thing. So that means it involves the development team and the operation team who look after the infrastructure. Okay, so that's why everything is all inclusive and everything is connected together, right? That means right now developers want to innovate and deliver faster, deploy the new features every minute, every second, right? But how can we make sure that everything is connected together, right? Operation team, that's the infra people, you know, think about the software side reliability engineer that who look after the production system, API server, the deployment server, that kind of thing. The application has to be deployed on that one, right? So how can we make sure that everything is connected, everything is continuous as a loop, you know? So that's why we have the DevOps testing practices here. We start planning, we use the Jira, Confluence, Bitbucket, Git, SVN, whatsoever. That's a continuous development. You use the version control system, you do the coding, okay? And then you can create a new branch, and each branch, new pull request will be test automatically as well using this kind of tool and techniques, okay? And you can use the test continuous integration as well. That's a CI/CD server. Jenkins, Bamboo, Hudson. These are the CI server who these kind of tools will continuously test the new pull request, every new pull request, every new commit that you submit to the GitHub or GitLab server, right? It will automatically test the code, and then once the code is fully tested, there is no bug, there's no error, it will continuously release and deploy using the continuous deployment open source tools like Puppet, Chef, Ansible, SaltStack, that kind of thing. Okay, and then when we deploy, we need to operate and monitor the software as well, because let's think about the operation and the monitor here is actually part of like a performance engineering, right? When the software has a high load, how can we ensure that everything is on track, right? Think about the e-assessment system. When there's no e-exam, no one uses it. But during the week 13, okay, week 14, there's an exam period. There's a peak load, right, in the e-assessment system. So they have to monitor the system using this kind of tool as well. Splunk, ELK Stack, Nagios, Sensu, or New Relic. Okay, this is an examples of the tool. You can Google to learn more as well. Okay, we will not cover most of the thing here. But in this unit, we will only focus on the unit testing here. So we're gonna use the JUnit for Java or the PyUnit for the Python. Okay, we will talk about that next week. Okay, yep. So the difference between DevOps testing and the previous testing process is that the DevOps is the loop, okay? But the previous one is just a separate phase. Think about this one. This is a separate phase, right? It integrates everything, but it's not the loop. This is a separate phase. Testing, integration, only one phase. This one, only the phase. Unit testing, integration, it never go back as a loop. Okay, it's not about the deployment at all. Okay, make sense, everyone? Any questions? Yeah, before I move on to the agile testing. Yeah, I'm gonna take a break a little bit and let everyone ask question. Any questions? No? Okay, I'm gonna move on to the next part. Will there be any flux questions? Actually, no today. Yeah. Yeah. Agile testing. Okay, so agile testing. Another question, how to integrate agile SDLC with the V testing model? No, we cannot integrate. Agile testing is the agile testing. V testing is a V testing. So it's not it cannot be combined to each other. Okay. Yeah. But I'm gonna talk about what is the agile testing. All right. Agile testing. The key point is that how can we make the testing process more agile? That's it. And how can we test in the agile team as well? When we talk about the agile Scrum project management, okay, probably I should go back to the first slide here. Okay. First slide, this is the agile Scrum project management. How can we test them, right? Should we test only here at the end, but it's not aligned with the shiplap testing? How can we test at the beginning? You know, it's like a misconception, because when we talk about the agile, we mostly focus on the working products rather than exhaustive documentation. How can we test them, right? Why we should care about testing? So that's why I'm gonna emphasize here. All right, what is agile testing? Okay, agile testing, I really like this concept. Okay, and I borrowed the content from this book, Agile Testing, a practical guide for tester and the agile team, by Lisa Crispin and the Janet Gregory. This book is really good. I really love it. And if you want to learn more, you can go to the Agile Testing Fellowship as well. They have like a fellowship program. You practice, you learn from the book, and then you can get the certificate as well. You know, if you want to become an Agile Testing Fellow as part of them, as part of the cohort, you know. So Agile testing, what does it mean? We in the past we talk about the qualitative collaborative testing practices that occur continuously from inception to delivery and beyond. I would say that agile testing, right, is the concept or the principle. You know, we want to support the collaborative testing practices, and it should occur continuously. Okay, it should support the frequent delivery of the software system. Okay, frequent delivery of value for our customer. Testing activity should focus on building quality into the product, using the fast feedback loop to validate our understanding, and the practices train and support the idea of whole team responsibility for quality. This is the definition by Lisa Crispin and Janet Gregory. I just want to emphasize that the initial keyword here, the collaborative, continuously support the frequent delivery of value, that kind of thing. This is like to align with the agile principles, agile values. But the key point of the agile testing should be about the whole team responsibility. This is really what I want to emphasize. When you work in the software team, right? You have 4 students working in the software product. It's not like, hey, look, student A, you focus on the feature 1, student B focus on the feature 2, but the student 3 and 4 focus on the quality. That's not really agile. Agile, I just want to emphasize, agile testing focus on the whole team responsibility for quality. So everyone who develop the feature should make sure that it is of high quality as well. Okay. In agile testing, testing is not the phase. Okay. But testing is one of the many activities in the software development, along with the coding, planning, design, architecture, operations, and more. So quality must be integrated throughout the whole, throughout the agile software process. Okay. Make sense? Yeah. And I saw a question in the Zoom chat. I will get back to that one after I finish the agile. Okay. So again, agile testing is the whole team responsibility for quality. And with agile, it's not only the tester or the QA team who feel responsible for quality, as I mentioned before, but and we also don't think it is a department as well. Okay. It should be the whole team. Everyone, this is the job for the whole team, not just the tester or designated QA professional. This is what I have mentioned already. All right. What do we value for? Okay. Testing throughout, over testing at the end. Okay. Testing at the end, this is the waterfall, right? But what do we value is that we testing throughout. When you write the code, when you have the new feature, you start testing it. We want to make sure that no breaks in the software at all. Okay. You want to prevent the bugs rather than finding bugs. In the past, we develop a crappy software, we detect at the end. And then we need to spend, like, let's say, half a year to fixing them. What a waste of time, right? So right now, we want to ensure the quality at the early phase of the software development. We want to prevent the bugs as much as possible, okay? Testing understanding over checking functionality. Okay, you want to come up with lots of testing scenarios. You want to understand what do you want to test rather than checking whether the functionality is correct or not, like in the past. Okay, building, you want to build the best system. Okay, rather than breaking the system. For example, when you develop the calculator app, sure, you can test the 1 + 1 = 2. Okay. This is like you want to build the best calculator application. But what do we mean by breaking the system? It's like you want to hack the calculator application. You want to find the bug that there is a less chance that the common user will find, like, for example, memory overflow whatsoever, that kind of thing. That's kind of when you break the system. You want to test the calculator app with the string or not? Probably it is something that is not that common, right? Who's gonna use the string as part or the character in the calculator application, right? Okay. We value the team responsibility for quality over the tester responsibility. When you work in the agile team, okay, when you work in a group for the assessment tree, there's no tester role. Okay, everyone should be the tester. They should test your own feature. Okay, whatever you are responsible for, you need to test your product. You need to test your own code. Okay, or at Google, normally they call dogfooding. So you develop something, you use them first before you release to the customer or the end users. Okay, make sense? When you agile testing, this is only the principles, right? The high level concept. But how do we actually do it? That's another story, right? That's a methodology here. There are three methodologies that are often used in the agile testing. First, it's called behavior-driven development. This is more like UI testing. You test the behavior of the software rather than the unit level. Okay, you test the behavior. For example, as a user, if they press 1 + 1 equal, it should return 2. That it should display 2 in the calculator. That kind of thing. That means you test the behavior of the calculator application. Okay, what do you need to do? First, you need to describe the behavior. Write the step definition. You run and fail. You write code to make the step pass, and then you run the code, run the test to make it pass as well. That's the behavior-driven development. This is a test-driven development. Okay, the next one is a test-driven development. First, you write the test case. You first actually you need to read the requirement. Okay, read the requirement. In the calculator app, there must be an addition function. Okay, this is the addition function. You understand the behavior, and then you start writing the test case. Oh, probably 0 + 0 should return 0. 1 + 1 = 2. -1 + -1 should be -2. That kind of thing. All right. Writing a failing acceptance test. Okay, you need to write the test case, and then you start writing a failing unit test, and then you make the test pass. That's how you write the code, and then you refactor it. Okay, so in short, again, sorry, you write the test case, write the code, make the test pass. Okay, and then you refactor it. Exploratory testing, so it's like a random testing. You learn how the software is behave. You decide the test case, you execute something, and then you analyze whether the test case is pass or fail. That kind of thing. That's more like exploratory testing. It's not systematic at all. Holistic testing. How can we combine the agile and the DevOps together throughout the process? That means it's like we use the DevOps testing, right? But we make them agile as well. Okay, the concept. Let's try to understand this one together. Okay, testing is done early in the draw. Okay, testing done early in the cycle. What do we mean? When we elicit the idea, elicit the requirement, we need to test the idea. We need to determine the values. Okay, calculator app. Let's say you want to test the idea. For the calculator app, do we need a login function? Probably no. Does it really deliver any values to the customer as part of the calculator application? The login feature? No, nothing. Seriously, nothing. Okay. You want to create a shared understanding, right? During the planning, you develop the calculator app. You identify the risk. You test the assumption. Create the testable stories. When you do the division, can we divide by 0 or not? This is something, the exception case that you need to identify. Okay, what the results, what are the answers should be. So when you during the planning, you may want to involve the mathematician as part of the process as well. Do we need to consider different types of the numbers or not, complex number, and once you understand, right, during the understanding phase here. So yeah. So planning and the understanding, you want to test to prevent defects. So you want to create acceptance testing. You want to create some example, try example mapping. You want to create some prototype, determine what events to monitor or observe, right? For example, division by 0. Okay, can we do the 1 divided by 0? Probably no. And what are the exceptions should be? What are the error message should be displayed to the end user? That's what you need to elicit the requirement, make it clear at the beginning, at the early phase, right? And now you can build it, right? For the add function, you build it, and then you can automate test, instrument the code, you can test the story. 1 + 1 = 2, test the feature, test everything. Automate, everything is automated. You have but the add function, just only one button here, right? But at the end, when you want to deploy, that's the whole application. Okay, it's not just only the addition function. So once you do the unit test, you need to do the integration test as well. Test the infrastructure, run the automate test, test the whole pipeline, test the quality attribute, whether the UI is good or not, efficiency, performance, test the whole system testing. and then you can release to the end users, right? So that's the test in production. Use the feature toggle. You can use the blue-green environment as well. That's how they have done in the top software companies as well. Okay, or they call A/B testing. Okay. And then you can observe the customer usage. Okay, so which feature that customer use the most, right? Like addition, subtraction, division, that kind of thing. These are the top 4 features for the calculator application. That's why the basic calculator app, they don't involve like a square root, like a scientific calculator, because they are less likely to be used by the general user, right? So that's how you observe the customer usage, and then you can monitor the warning as well. When the end user, when the customer use the calculator app, whether it shows any errors or bugs or incorrect calculation or not, right? And then you can observe and develop some hypotheses. You learn from that, learn from mistake. Is there anything wrong with the application? Why the users don't press this button at all? Is that in the right order, in the right format, in the right UI, that kind of thing. So once you learn it, then you can improve it, right? Create a new features for the next release. Everything becomes the loop, okay? That's the loop. You combine agile testing and that DevOps together. All right. Wow. Okay, next. Okay. So these are the 12 the 8 principles, okay, that we need to follow for the agile testing. As I mentioned before, we focus on the continuous testing, continuous feedback, right? You monitor them, you use the feedback as a loop back to the development team. You understand why, what went wrong in the past, how can we improve it in the future. You can involve the whole team as well. You should involve the whole team when we talk about the agile testing. You want to get the quick feedback from the end user, from the business team. We only focus on the high level software quality, right? And we focus on the less documentation, just enough documentation. It doesn't mean that less documentation is no documentation. We need to document something, okay, but less than the waterfall style software quality planning, that kind of thing. Agile testing is quite test driven. Okay, the product is evaluated at the time of the implementation. You implement it, you test it immediately, not at the end. Okay, and you focus on the customer satisfaction, not your satisfaction. All right. Okay. Let's go back before we move on in the Zoom chat. Okay. There's a question. What are the responsibility as DevOps engineer? What are the difference with system analyst? Yeah, I would say that, okay. I would say that different organizations have different role or different job description. It really depends, okay. But to me, it's different role. DevOps engineers, I would say that they look after this part, okay. Deploy, release, DevOps engineer. That means they focus on set up. Maybe I should go back to the DevOps testing. 1 second. Yeah. DevOps testing. So DevOps engineer, all right, they want to set up this part, this tool. They create the infrastructure as a code, okay, infrastructure IAC script for the Puppet, Chef, Ansible, that kind of thing. For example, let me give you, how can I give you an example? Let's say you want to deploy one feature, okay, in the cloud. It has to be an API. And how can we deploy that kind of feature to the 4 million users? Okay, there's a peak load there. So it's an API and deploy on the cloud. And then you need to configure the virtual environment. You need to define what is the CPU, what is the CPU size, what is the memory size, what is the disk size, that kind of thing. That's how you configure the infrastructure as code, IAC script, which can be used in the Puppet or Chef, that kind of thing. Okay, that's the DevOps engineers. Okay, they develop the DevOps script infrastructure as code script, that kind of thing, to for this part, okay, to make sure that the pipeline is continuous. Okay, make sense? Yeah. For the system analyst, it really depends. Sometimes they sometimes it depends how do you define it. System analyst could be like a business analyst as well. They analyze the system during the requirement phase, okay? Or it can be system analyst, could be like a site reliability engineer who look at the infrastructure, everything, that kind of thing. Yeah. So it really depends, you know. Is that help? Yeah. Yeah. All right, so the next one is the agile testing quadrant. Okay, what does it mean? Why do we need the testing quadrant? So I would say that it's about the 4 aspects of the as part of the agile testing. Okay, what do we focus? Okay, it depends. So when we do the agile testing, let me see. Okay, so we have the quadrant 1 here. Okay, 1, 2, 3, and 4. Okay, so for the quadrant 1, we want to focus on the quality of the code. That is the first step, right? You look at the code, you do the unit testing, everything can be automated. It's a little bit technology facing, because you test the Python code, test the Java code, that kind of thing. Okay, and it is you want to test your own code. Yeah, that's the first step, right? Once you test this one, then you can do the quadrant 2. Okay, so it's more about business driven test cases. Okay, test the scenarios which may occur, workflow, test the user experience, that kind of thing. So you look at the functional testing, story, user story testing, you test the prototype. Okay, and now the once you finish this part, this one can be a little bit of the automate or the manual as well. And the next step, right, you need to test the quadrant 3 here. So you want to do the exploratory testing, usability testing, user acceptance testing, alpha, and the beta testing. Okay, the quadrant 3, you want to provide feedback for the previous 2 phases. Okay, and the last step before we deploy to the production environment, that's a quadrant 4. Okay, so you actually focus on the non-functional requirement. Okay, you look at the performance, the load testing, the security testing. I cannot say that non-functional requirement is not important as part of the agile testing. It just happened at the end, okay, before the deployment. Do you know what I mean? Okay, we didn't say that we ignore the non-functional requirement as part of the software testing, but we would say that functional requirement is the first priority. You need to focus or prioritize your efforts on the quadrant 1. The functional correctness must be the utmost important. Okay, followed by the other aspect. Okay, make sense? Yeah, that's the agile testing quadrant. All right. Yeah, that's 1 hour past. Now I'm gonna talk about the software testing. Okay, software testing. Yeah, so what does it mean? Software testing, surprisingly, right, when you consider the amount of effort, okay, in the software development project, some way, somehow, 50% of the effort that you spend in the project is about software testing. You develop probably 20%, 30%, elicit another 20, 30%, but the testing is actually 50% of your development effort. So when you do the assessment tree, make sure that you prioritize your project really well, okay? Software testing is a process of the evaluating and verifying that a software product or application does what it is supposed to do. Okay, and there are different types of the software testing here. For example, usability testing, non-functionality testing, threat testing, load testing. There's so many things, right? But in a more systematic way, okay, there are two high-level software testing technique. Okay, we look at the dynamic and the static testing. Okay, dynamic and the static testing. All right, static testing, it means that we look at the code, we don't execute the code, and we find the bug. Okay. To do that, we normally use the code review, code inspection, take review. Let's say you look at the code, a plus b should, I mean addition, you take the two parameters a and the b, and then you want to return a plus b instead of a minus b. That's how you look at the code statically. You don't execute the code dynamically. Okay. And for the dynamic method here, there's an ad hoc as well, but I would say that there are two key points here. Okay, the white box testing and the black box testing. Okay, white box testing, you execute the code. You normally look at the unit. There are different techniques. Okay, as part of the white box testing, that means you look at the code. Okay, you can use the unit testing, integration testing. Black box testing is about you create the test case based on the requirement. Okay, so it's more at the system testing level or the UAT level. I will talk about that in the next few weeks as well, so don't worry. Yeah, so just want to emphasize here. Okay, software testing technique, there are two key approach. Okay, two key methods here: dynamic and the static. Static, you don't execute the code. Dynamic, you execute the code. Okay. For the dynamic, there are two approaches here: white box and the black box. Okay, we'll talk about that later. Yeah. All right. There are 4 levels of the software testing. Okay, unit testing level, integration testing level, system testing level, and the acceptance testing level. If you remember the V model software development, okay, unit testing is like at the lowest level of the code. You have the add function that take the a and the b parameters. You want to test whether it should return a plus b or not. That's a unit testing. Test only one method, one function here. Integration testing, you test like several operations together. Let's say a plus b minus c multiplied by d, that kind of thing. That's how you integrate multiple functions together. Okay. System testing, okay, you test the whole system to check it's compliant with the given requirement, including non-functional requirements like performance, reliability, and the security. You test the whole system, press the button, everything, okay, the calculator app. Acceptance testing is when you let the user test the software system, okay? You develop the calculator app, hand over to the end users, let them test it, whether they are happy or satisfied with the requirement or not. Okay. Yeah. When we do the software testing, right? There are different terms and technique. So there are different keywords here. What are the difference between fault, errors, and the failure? Okay. These are the 3 terms that can be used not can be used. I would say they are often used interchangeably, but I would say that they are not the same thing at all. All right. Fault, it is a mistake in any phase of the software development process or design in the implementation, fault or flaw. Okay. Bugs is the runtime manifestation of a fault. Okay. Symptom of an underlying problem which may result in a failure. And the failure is something that is like exposed to the end users, to the customer, to the outside environment. Okay. Which makes it not meeting the criteria. Let me put this way. Let's say if you develop the addition function for the calculator app, instead of a plus b, you say return a minus b. Okay, a minus b, that's the flaw. Okay, that's a flaw in the program, which cause a bug. Okay, cause a bug later on when you execute the test case. That's a runtime manifestation. You execute the code. Okay, 1 plus 1, but return instead of return 2, it returns 0. That's a bug in the system, in the calculator app, and which cause a failure, right? At the end, failure, it means like, hey, I'm gonna use the calculator app, but something is wrong. That caused the failure. I cannot sell the products correctly. That's a failure. Okay, it is external to the program. Make sense? Any questions? Yeah. There's a difference between the fault, error, and the failure. All right, failure to the like how the bug actually impact the end user. Okay, external the program. That's the failure. software is crashed, the blue screen of the window, what else? Yeah, that's a failure, you know. Okay. Actually, that is an example as well. Let's take a look at this example, right? Data validation in a Google form, let's say Google form, which asks about age of the user, okay? The error could be the form accept negative values for age, right? Normally the age should not accept any value that is negative. And the failure is that the form submission crashed when the user input negative value for the age field, okay? That's the failure. Another example, this is for the payment processing feature in an e-commerce application, right? When you when the place order button is clicked, okay, the error could be that the system calculates the total amount due incorrectly, but it proceeds to the payment transaction, that kind of thing. That's an error in the system, but it caused the failure to the end users as well. That means the system encounters an internal server error and fails to complete the payment transaction, that kind of thing, okay? Anything that is external to the software, we call it failure. Make sense? The key principles here is that testing can only prove the presence of the bugs, but not their absence. Let's say you have the addition function, right? You have the test case 1 + 1 = 2. How can I say? No, sorry. Maybe I would say I should use the division, okay? Division. 4 divided by 2, it return 2, okay? It return 2. Everything is correct. I don't find any bugs. So testing can only prove the presence of the bug, but not their absence. If I don't have another test case that tests whether 4 divided by 0 or not, then I cannot find the bug, you know, okay? So testing only proves the presence of the bug. It only shows what they found, but not their absence. In real world, testing is really hard and complex, okay? This is the real world software application. You have the web application, you have the desktop application, you have the mobile app presentation tier here, mobile apps and the client. You have everything is connected via the API, okay? And the API also connect with the logic tier as well. That's a business tier, data access tier. The logic tier also connect to the data tier, the database, you know, SQL server. Everything is so complex. How can you make sure that everything is correct, right? So that's why software development project is actually really, really expensive. How many software engineers are involved as part of this architecture? So complex, so expensive. Yeah, as I mentioned, right? Software is really complex. Requirements are subject to change over time. Small change can have huge repercussion as well. The time and the resources are limited. As a CEO, we want the next feature tomorrow. How can we do that, right? So that's why we need to make sure that the process is efficient as well. We have the lack of access to the real world environment. We have several iPhone devices, you know, different iPhone version, different Android version. How can we test everything? And do we really need like hundreds of the mobile applications? Probably no. That's why we need to set up the simulations as well. Okay. All right. When we talk about when we talk about the testing, right? We need to look at how to test and what to test as well, and which is part of the testing plan. Okay, testing plan here. In the waterfall style, okay, we need to develop the test plan to understand what to test and how to test it, okay? That's why we need to write the test documentation. That's a waterfall style, okay? To test the software product, right? This is a journey. Normally, we need to analyze the requirement, understand, oh, this is a calculated application. Now we develop the test plan. Okay, any feature that we develop, we're gonna develop the test case based on these test scenarios, blah, blah, blah. And now we decide the test case, you know, because this is the addition function. So probably 1 + 1 = 2, 2 + 2 = 4. Test execution, we execute the test case, write the test case. Once you find the bug, you report a defect, right? Using like Jira or the GitHub. And then you retest it. Once everything is passed, then you can release it, okay? That's the journey to the software testing, all right? This is an example. What is that? Examples of the requirement for a mobile banking application, right? You have the functional requirement here. User should be able to register for the mobile banking app and using their personal information and create a secure login. This is a functional requirement. Okay. Next, you need to come up with a test plan. What is the goal of the test plan? This is the background. What is the test assumption? How do you test it? What is considered as our obstacle? What is the strategy, test strategy that you want to test? What are the features that you want to test? That kind of thing, okay? And what is the release plan? Yeah, and what is the timeline as well? The critical date, you know? This is just an example, okay? Test plan documentation. Then from the requirement, this is during the first step, right? Requirement analysis. From the requirement or the user story, you want to write the acceptance criteria. This is what you have done already. In the requirement, yeah, in the product backlog, break down into the user story. One user story can have multiple set of the acceptance criteria, okay? And each of the acceptance criteria, you should also have the definitions of that as well. What is the set of criteria that user story or product backlog item must meet to consider complete, okay? This is, we have learned this one already. Yeah. This is an example. You have the functional requirement here. User should be able to register, blah, blah, blah. You write the user story. As an user, as an end user, I want to register for the mobile banking application, blah, blah, blah. And this is the step, okay? Write an acceptance criteria. First, the mobile banking app should provide a registration feature. The app should validate the information, blah, blah, blah. Upon the successful registration, the user should receive blah, 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 blah. The app should securely store the personal information, sensitive data. The login feature should show this. The app should do this, what it should do. You know, this is the acceptance criteria. And when we test it, whether this user story is met or not, we want to make sure that the 11th step here must be met. Yeah, otherwise we cannot consider as done. Okay. Yep. This is an example too. And and how can we ensure that every requirement, every user stories are well tested, right? So that's why we need to create the requirement traceability metrics as well as a mapping table, nothing more than that. It's just a tool to ensure that each requirement has a corresponding test cases, right? And we have the requirement ID here. This is a requirement description. We have the user story IDs that are mapped to the each of the requirement. And then we have the test case ID here, okay? Just a table, mapping table. You know, this is called requirement traceability metrics. Once each of the test case is executed and done, you can tick as well, okay? And then this is just to make sure that every requirement is met and it is well tested. That's what I mean, okay? Nothing more than that. Easy. Once you create the requirement traceability metrics, now you need to create the test plan, right? So the key point of the test plan is about what you want to test and how to test it, okay? So normally to create the test plan, right? You want to analyze the product, decide the test strategies, define the test objective, define the test criteria, find the resource as well, okay? It's quite exhaustive whatsoever. And then but the key point, okay, I think let's jump to the key point here. Because in Agile, we normally don't develop the exhaustive test plan, okay? Next step, once you come up with the plan, you need to decide the test case here. What does it mean by the test case, okay? If you look at this one, this is the test case ID, okay? Each test case ID, there's a one test case, okay? And what is inside the test case, okay? First, the test case must consist of the unique ID, okay? Unique ID. It should provide the test description. It should detail what the unit, the feature, function is being tested. Let's say we want to test the addition function. Is there any assumption or the preconditions? Addition function, probably no. But for the division, we want to make sure that the denominator must not be zero, that kind of thing. What is the test input? There's a test data. 1 plus 1, okay, equal to A equal 1, B equal 1, return A plus B. That means return 2. What are the steps to execute, okay? What are the expected output? Normally, 1 plus 1, it should equal 2. Once you execute the test case, we talk about what is the actual output. If it is true, okay, same output, then we consider it as pass. Okay, this test case is pass. If the output is different, okay, different output, we consider that test case is failed. 1 plus 1, it returns 0. So probably it's failed. Okay. Look at the figure here. This is a test case here, right? System under test, software under test, that's the calculator application. The input, okay, to the calculator app, normally what is the input here? The test input, okay, and the expected output. Input is a and a B. A equal 1, B equal 1. 1 plus 1, it should equal 2. That's the expected output. We feed the input and the expected output into the calculator app, okay? We look at the actual output. If it is 2, we compare the actual output with the expected output. If it is 2, the test case is passed. If it is different, then the test case is failed. Okay. The concept is there. Any questions so far before I move to the next slide? Any? No? Okay. So if you have any questions, you just type in the Zoom chat. Otherwise, I will continue. Okay. Once you create the test case, normally we need to create the test case document, okay, to map everything, right? This test case is, what's that? This is the project name, the project calculator app, the module name. We talk about the addition whatsoever, blah, blah, blah. We have different test case ID, right? We have test scenario. We have the test case as well, okay? A equal 1, B equal 1, 1 plus 1, it should equal 2. This is a step to test. What I mean is that we just basically map whatever we have here into the table, in the document table here. So we can make sure that whether the actual results, whether the status of the test case is pass or fail. Intuitively, okay, we want to make sure that every test case that we design is passed, right? Yeah, so that means we develop the software correctly. The functionality is correct and it is completed as well. We develop the test case for every features that we want to develop, you know. Okay. Once you develop this, the test case document, now you need to execute the test case, okay? So once you execute the test case, then once you find the bug, then you just submit the report, the defect report, okay? But right now, when we, because in real world scenarios, in real world software development projects, right? Software is really large. We cannot manually execute the test case. That's why right now we often use the test automation, okay? There are lots of tools. I will talk about that in the next few lectures as well. Don't worry about that. Yeah, everyone is going to do the test automation, do the unit testing together, okay? And then what is that here? This is like the high level concept. How do we do the test automation throughout the Agile or the DevOps life cycle, right? So during the Agile development, we have the daily stand-up meeting at the product stage, right? No, sorry, we have the product backlog here. Every 2-week sprint, we want to deliver the final products. As part of that, we can the developer, maybe I will draw here, okay? The developer normally commit the code, okay, to the code repository. The code repository is connected to the CI server like Jenkins or the GitLab CI. It will run automate tests, don't worry. And there's a repository manager as well. So basically the CI server will tell you whether the new code contribution is correct or not, okay? So that's part of the CI, okay? CI, yep. And you can look at monitor the code quality metrics as well, like how many bugs are found, how many pull requests are failed, how many, whether the code is too large or too complex or not, okay? During this part, okay, you can do the continuous testing here, okay? You can write the test script come up with the test suite, execute in the CI server, and the test script here can be the integration testing, user acceptance testing, or the QA, everything. If the test case is failed, then it will automatically create the ticket in the issue tracking system, okay? And it will provide the feedback loop to the developers, that kind of thing, okay? This is the test automation. And once everything is passed, it will go to the continuous delivery part here. So as I mentioned before, DevOps engineers had to write the infrastructure as code script to provision the software or into the API server whatsoever. So that's a little bit, I would say, beyond what we will cover here, okay? But this is something that is used in practice, okay? But I will not cover that much. Yeah. All right. This is a how crazy, you know? This is a real world test automation tools, okay? Looks like crazy. There are lots of tools for each for different levels, right? At the unit level, okay, within this unit we will only focus on the JUnit. This is the unit testing library for Java, and we will use the PyUnit for Python. All right, we can automatically test the functionality of the software system or the UI as well. The well-known one, I would say, anything that I'm aware. Not really. Oh, Selenium. Selenium here is quite well known. Okay, Qmetry is quite well known as well. So these are the two that is used for the UI testing. All right, and for the acceptance testing, these are the two we can use. This is a very well known robot framework. They just write the script and automatically test the system. Okay. This is a Selenium. It is quite well known as well. You can do the penetration testing, performance testing. You want to test whether the software is of high performance, good performance or not. You want to test the browser, different UI, test the API. Normally we use Postman, okay, to test the API. And because in real world there are lots of test cases, we need to manage the test case as well, you know. And there are different companies that provide testing service as well, like Deloitte, Accenture, Tata Consulting Services, that kind of thing, you know. Wipro, yeah, we have Wipro in Australia as well. Yeah, that's a test automation tools. All right, and once you develop the test case, if the test case is failed, you need to submit a bug report or defect report. Normally we use the issue tracking system, right? There are different issue tracking systems like Atlassian Jira, the Bugzilla, or the GitHub, okay? And these are the life cycle, right? Normally, once you found a bug, okay, it can be from the end user, the customer, or the developers. You found a bug, you create a new bug. When you have the new bug, you need to assign a task to some developers who own the code, and then that developer, they need to resolve the bug, okay? Resolve the bug, resolve the bug, fix the bug, everything. There must be someone else to verify, QA verify whether it is the bug is fixed or not. If not, the bug is reopened and back to the resolve part again, okay? They need to fix it. Once it is verified, everything is fixed, then the bug can be closed. This is the life cycle, okay? And how to write the bug report effectively, right? Normally, this is an example, okay? This is an examples of the bug report. Left is the Jira, the middle one is the, what is that? Git. Should be GitHub, yeah. The middle one is the GitHub, yeah. And the right one should be the, what is that? GitLab, yeah. Bug report template, yeah. So for the bug report, right? Normally, these are the key components that should be included in the bug report. First, it should describe what the bug is, okay? For example, calculator, this is a calculator. Incorrect results of the multiplication. Okay, now we know the multiplication feature is incorrect, right? What are the steps to reproduce the bug? Okay, we need to provide the step as well. Okay, they are irrelevant. Okay, just an example. What are the results and the expecting the behavior? Okay, the results of the operation 2 multiplied by 2 should be 4, but it turns out to be 5. That's the incorrect behavior, right? You can attach the screen recording or the screenshot as well. You can provide the technical data, that kind of thing, blah, blah, blah. Otherwise, these are optional, okay? This is the real world example, okay? Yep. So this is a Hadoop system, okay? A kind of like a cloud computing system, you know? So this is the ID, bug ID, okay? Hadoop 16810. This is the title. Increase entropy to improve cryptographic randomness of blah, 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 pre-commit. It is classified as bug, okay? Priority, this is a blocker, okay? We need to fix this one ASAP, okay? Status right now, it is in progress. It's not fixed yet. They provide the description as well. I was investigating a JUnit. This one, they tell the scenarios, right? Like how to reproduce, you know. I explore 2 different options. The first solution, blah, blah, blah. That's how they suggest the fix, that kind of thing. This is another bug report template for GitHub, okay? 001. First, this one is written by Felix, okay? Step to reproduce the bug, blah, blah, blah. Results and expected behavior, blah, blah, blah. Screen recording, blah, 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 okay? And they add as a bug, that kind of thing. And this is also similar for the GitLab as well, okay? Bug report template, yep. This is a template that we should write, okay? Ideal template. Yep, I think, where are we? Okay. Oh, some way, somehow, I actually come to the end of the presentation slide. Okay, so in short, right, we talk about the journey to software testing. Okay, I for this lecture, I only covered the requirement analysis. You analyze the requirement, come up with the test plan, decide the test case, execute the test case, and submit the defect report, that kind of thing. Okay, once everything is well tested, then you can release to the customer, okay, to the end user, release to production. All right, that's all for today. Actually, any questions so far? I am open the floor to everyone. Any questions? If not, don't worry. So there is a few things that I want to remind. What is that? The assessment 3 will be released very soon as possible. Okay. The assessment 4, same as well. You will need to involve the coding and the software testing. Next lecture will be a little bit more hands-on and technical. So I will teach you in the lecture as well how to write the unit testing in Java and the Python. Okay. So try to attend the lecture as much as possible. Okay. Don't miss it. Otherwise, it will be a little bit difficult to follow up as well. Okay. So try to attend the lecture. When will the assignment 1 marks will be released? We plan to release by this Wednesday. Okay. So please bear in mind, because we just finished the mid-semester break. We need a few more days to finalize as well. Okay. Yep. Any other questions? Do you enjoy the unit so far? What do you think? Yeah, so I hope that you enjoyed the unit so far. And if you have any feedback, right? If I go too fast, if I go too slow, if you need anything that need to be covered, write in the EdSTEM feedback, that one as well. I just want to emphasize that every message from you is read by me, okay? I read everything, okay? And that's all for today. This is week 6. Next week we'll talk about the unit testing, code coverage. It will be a little bit more technical, so try to attend the lecture as much as possible. Is there going to be a discussion regarding A2 and how we are supposed to approach the planning process, especially the sequence diagram, since we haven't really discussed on it in the apply session? It will be in the apply session this week. Okay, this week we will talk about the sequence diagram, the detailed class diagram. How can we look at the design quality as well, coupling, cohesion, that kind of thing. Yeah, we will talk about that within this week. Next week, apply session will be about the EDSTEM unit testing. Okay, so next week everyone will practice the unit testing in Java and the Python. Okay, it is going to be fun. Yeah, we will write the calculator application together, and then we're gonna test the calculator application together as well. Once you get to know the first calculator app, then there will be a bunch of exercise for you to practice as well before the real assessment fall. Okay, it's going to be fun. Yeah. That's all for today. I hope you enjoyed the lecture, and yeah, see you everyone in the apply session. Bye bye.